Alright, so we're going to take a look here at inverse variation problems. Now, we talked about direct variation before. I said it was kind of like gas prices. Okay? The more gas you put in, the more it costs you. Now, inverse variation is going to end up doing the opposite of that. Instead of it growing, it's going to be smaller. The example that I would have for that is, say that you're going to have a beam that's going to span whatever distance. Now, if your beam is just going to be a plain old 2x4 and you're just going to have it span over 4 feet, that's not too bad. It can handle the weight. But what happens if I'm going to put that 2x4 over 20 feet? That 2x4 cannot handle that same amount of weight on a span that's longer. That's why you need a heavier 2x4 or a heavier beam. So this is the idea that here's something's getting longer and it's going to be able to deal with it less. So that's what inverse variation looks like. Now the inverse variation is going to get set up like this. Y is equal to our k over the x. Basically, they look at a typo in there. Y is equal to k over x for an inverse variation problem. Direct variation is always multiplication. So let's take a look at this. Okay, so this represents something that's going down. As we increase, I double this number, this gets cut in half. Double that number gets cut in half. Now another example of that would be, they always say that when you buy a brand new car, you drive it off the lot, drops $2,000 or gives you a dollar amount right away. Depreciation is what happens on that vehicle. I mean, it's worth less as time goes on. So if you're dropping 10% of the value of a new vehicle every year, we only hope that it wouldn't do that. After 10 years, it's worth nothing, right? By that idea, but after a while, there's a rock bottom price that it will always work at. So the question is this an inverse variation? Is it always going down by the same amount? Now, like I said here, this up here doubled. So I end up multiplying this by 2. Multiply that by 2. Is the same thing happening down here? It's going from 2 by 1, so what is it going by? Half, right? What about from 1 to 0.5? Is that another half? Okay. So when we're looking at this, we see that, okay, how is this responding to what we're doing? We're going up by the same amount all the time, and it's going down by the same amount all the time. So in this case, we're going to say that it does have this, and what is the constant of variation here? We would end up saying that k is going to be equal to what? Because now this has to be y is equal to k over x. What's happening to it? Y is equal to k over x. So the constant of variation is going to be, if y is here and x is here, guess what k is? 2. Okay. Now, the reason why you're kind of looking at this confused, well, I thought you said it was half. Yes, because a direct variation multiplies up, inverse variation goes down. Okay? It's getting cut in half. So, my question for you, what would be the value when x is 8? What would be 8 here? So if I continue this pattern, this was multiplied by 2, and what should this be doing down here then? if it's going to continue this pattern. That this is going down by what? Half. This one's going down by half. So should this go down by half again? So, what is half of half? Quarter. 0.25. As this increases, it's going up. Now, what happens if I just wanted to take my x and put it into here? If we said that y is equal to 2 over x, what's x? 8. What is 2 over 8 simplify down to? Does that simplify down to 1/4? Is it 1/4 the same as 0.25? There it is. What you really want to try and do here is determine how it's changing. If you can make that determination, life is going to be a lot easier. Let's think about this one. So I want to know whether or not this is always going to work. How is this going up here? How does this change? Well, I mean, it's going up by +1, +2, +3. When we were looking at this over here, we had 1, 2, and 4, right? They're multiples of each other. So what I want to look at is I want to look at the multiples. Okay. 2 to 4. How does that go? From 1 to 2 to 4. What's it doing? How is it changing? What is it giving us here? One of the ways to start with this, y is equal to k over x. What you should do is, are you given an x? Are you given a y? So if I put in x as 1, y as 3, what does k have to be equal to? Yeah. K, come on. K turns out to be equal to 3. What about this? Try this one. I want to find k. So now I've got 2 and 1.5. If k, let's see, y is 1.5, k over 2. What do I got to do to both sides in order to figure this out? Won't I just multiply by 2? And doesn't that cancel out there? And what is 2 times 1.5? 3 is equal to k. Now, there are a lot of different ways of dealing with this. If I want to see what is going on here, I want to go and check and see if that's going to be the case. Now, if I set up my variation equation, it's going to be y is equal to 3 over x. Okay, that's the variation equation. So, if I put 1 in, I get 3 over 1. Does that give me 3? Yes. If I take 3 and divide it by 2, do I get 1.5? Yes. If I put in 3, what's 3 over 3? Is 3 over 3 the same as 1? Yes. If I put in 4 down here, 3 over 4, is 3 over 4 that? Is 3 over 4.75? 3/4 is how much money? 75 cents. Okay? By going through and picking these out, we can determine whether or not we actually come up with the inverse variation. For those of you paying attention, following along, pretending you're interested. Let's try this one. Let's see if that idea works again. Now again, we've got y is equal to k over x, inverse variation. So if this is working, I should get the same k here and here. Would that be correct? So if I put in 25 is equal to k, x is 1. Well, k has to be equal to 25. Is that true? For that particular problem. Now if I go over here and I say the same thing, well, y is 10, it's equal to k over and x is 2. Well, multiply by 2 to both sides, multiply by 2, and I get 20 is equal to k. Did I get the same constant? No. Let's try this one over here. If I put in my y of 3 is equal to k over 3, multiply both sides by 3, I end up with 9 is equal to k. My question is then, is this actually an inverse variation equation? And the answer would be no. Why? Because my k turned out to be different, and all I got to do is find one thing that doesn't match up. Okay? One thing that doesn't match up and we're done. Does that make sense? Now, I'm going to show you the pattern up here again when I was talking about doubles. Okay? If I double it from 1 to 2, I cut it in half, correct? If I double from 2 to 4, it got cut in half again, didn't it? Okay. So, pattern holds. Now, if I were to go out and find 6, I could triple it. If I were to go from 1 to 3, that tripled it. Did I divide by 3 when I go from 3 to 1? It's a third of it. Those little connections kind of help. You can see that. Now, if you take a look down here on B, if I double it, did I cut it in half? No. I doubled it. Did I cut it in half? No. So, it didn't hold. And we found that out down here with our K's. It did not hold. So, now, the other one that we've got here is joint variation. So, make sure that you put this one in here. Now, they've got this in here that z, x, y, and k. I'm going to rewrite it the way it would normally be. Y is going to be equal to k multiplied by x divided by z. Okay? How do I know that? Well, if I were to go and solve this thing for y, this is what I would end up with. Okay? Oops, y is on the bottom, wrong place. I screwed that up. My brain told me one thing and my hand did the other thing. Sorry. One is going to get multiplied, the other one is going to get divided. Joint variation. Now again, if you want to sit there, where in the world would you apply this? Think of the 2x4 again. If I had that 2x4 span expanded out, and if I doubled the 2x4, so I had two of them, was actually a 4x4, would I have more strength? Would it be able to hold more weight over that 20 feet? And the answer would be yes. Okay. So, depending upon how you change things, you got to be very careful with it. So now, science. It says the force of an object of mass m that causes it to move with acceleration a can be found by the equation F is equal to ma. Is this an example of joint variation? Is it? actually the answer would be yes, because I got that m and that a over there. What would be the constant here? Do you see a k? What would be a constant if you don't see a number in front of it? If you don't have a coefficient in front of a variable, what do we call it? What number do we put there? So k is equal to 1. So f would be equal to k, m, and a. Why is it going to be joint variation? I have two things there, more than one. So if it's got to be more than, if it's more than one thing, it is going to end up being a joint variation equation. Okay? You don't have to have an inverse and a direct variation. You just got to have more than one. So let's try this. It says the kinetic energy of a moving object is based on its mass and the square of its velocity. Use the data set to determine whether or not this is going to be a joint variation equation. Okay, so the kinetic energy, okay, is based on its mass and what? Velocity squared. So if I take a look at this, let's see. We're going mass 1, 2, 3, 4. Okay? So the kinetic energy, is it going up? 2, 9, 16, 25. Is it going up? Yes? No? Maybe so. How do we deal with this? What we need to do, it says kinetic energy. Now we had this I don't like it because it's got a K in there. Kinetic, or constant K, and then it's going to be what? Mass and what? Velocity squared. So, is that always going to be the case? Well, let's check one. Let's take this. What's the kinetic energy? 2. Okay, what's its mass? 1. What's its velocity? 4. So that's got to be what? What do we put in there? It's a squared number, right? So we're just going to put that in as 4. So I solve this. 2 is equal to 4k. Divide by 4, divide by 4, and I end up with what? 1/2 is equal to k. So, if this bears out again, will it be correct? Let's put it in there, see what we come up with. So we're going to get k is our 9, k constant. What is m? 2. What is velocity? That's going to be 9. Okay, so I get 9 is equal to 18k, divide both sides by 18, divide both sides by 18, and I get 1/2 is equal to k. So, is this a variation equation? It looks like it's going to be. So, if I wanted to double check that, now that I think that my equation is going to be KE is going to be equal to 1/2 mass volume squared. So KE is equal to 1/2. Let's try the next one. Mass is 3. Volume squared is 16. 2 goes into 16, I get 8. 3 times 8 is 24. Is that what it predicted? Okay. Now I realize there's a lot of stuff here. Okay? I understand that. You just need to take a look at what is going on with it. So, when it said that it was based on its mass and the square of its velocity, it did not say inversely. So you don't have to worry about it. It's all going to be multiplication. You guys played with this in science, so gotta love science, right? So, it says an electric circuit. The electric power is the product of the square of the current I and the electrical resistance R. Write an equation that represents this. Okay, so what's coming out of this thing? What's the output? Is it power, is it current, or is it resistance? Power. So we get P. P is equal to my constant of variation. I have no idea what it's going to be yet, but I'm going to put it in there. Square of the current. So I is going to look like what? I to the what? Would it be I squared? Okay. What's the resistance? Is anything happening to the resistance? No, just R. So the function actually looks like this when you take a look at it. Well, I suppose Sundberg would be looking at that when you guys are doing circuits and electrical down there, right? Talk about this. Power is equal to I squared times R. How much current you got going in there, how much resistance, that's how much power you got coming out. Basic electrical. So, now my question is this joint variation? Yeah, it would be joint variation. It's not all that difficult to figure out what's going on once you get the idea. It says two objects of different masses experience a gravitational force of attraction. Newton found that this force is proportional to the product of the two masses. So, force. Product of the two masses. Well, that would be mass 1 and mass 2. This you've seen in science. Is there going to be a constant of variation in there? There's always a constant of variation. Sometimes it's just 1. So force is equal to K times M1 times M2. What type of variation is this? Is this direct variation, joint variation, or inverse variation? Well, how many pieces do you got in there? 2. So if it's more than one piece, it's got to be joint. Doesn't matter where the stuff is at. If it's more than one, it's going to be joint. So, now it says that Newton also found that the gravitational force of attraction F sub g is inversely proportional. Inversely proportional. So I'm going to have a what going on there? Division. Okay. So I know that F of g is going to be equal to K over something. I know it's going to be there because I've seen that word inversely proportional. Inversely proportional to the square of the distance. Okay? Well, that would be d squared, correct? Distance is squared. Square of the distance. So that would be M1, M2 up there. Would that follow with what it says? Okay. So we know that it's going to be multiplied out like that. There we go. Does that make sense? Yes or no? I know, boring you guys to death. So, give this a whirl here. Now, on C here, it says Newton's universal law of gravitation shows that the gravitational force of attraction is both a joint variation and an inverse variation. So, what I had written down here is the combination of those two. Because when it said inversely proportional to the two masses, I went and jumped right ahead to it because that's what it would look like. Okay? So we've got those there. Okay. What I'm going to do is I'm going to give you a minute or so here, and I want you to determine whether or not, or just answer this question. when I look at this to begin with, it sort of kind of looks like it, doesn't it? Like it would be an inverse variation equation. I mean, as this goes up, this goes down, yes? So I know that it's inverse something. Something's making it go down as my numbers get larger. I look at this here and I see that, hey, it's doubling here, and hey, it's getting cut in half here. Okay? If I go over to 4, well, that doubles again, and it gets cut in half again. So it kind of looks like it is. The only troubling part is right there, isn't it? I don't know if that's real. So, we know that it should be y is equal to k over x, correct? Y is 4, k, x is 1. Well, what's the constant here going to be? Constant is going to be equal to 4, correct? So, let's put the 2's in there, see if it works out. So if I put in 2 is equal to 4 over 2, correction. So y is equal to, and I put in the 2, does y equal 2? Is that what I got out? Yep. So I put in my x is 2, 4 over 2 gives me 2. So y is equal to, let's try this again. If I put in the 1, 4 over 1, I put the wrong number in, didn't I? Shame on me. Put in my x of 4, 4 over 4. Is that equal to 1? Did it work? Yes. Because remember, our equation is going to be y is equal to 4 over x. If I put in my x, I get out my y. So what about this 3 thing? Y is equal to 4 over what? What's my x that I'm putting in? 3. So is that equal to 1 1/3? So is this an inverse variation equation? Yes. What is the constant of variation? 4. Kind of looked like it, but we had to go through and check. Now, is that kind of a pain in the backside to run this through all the time, manually calculating everything? Well, that's easily solved. Grab the graphing calculator. Once you've got this piece over here, once you've managed to get to this, okay, we can pop that in and help us out. So, y is equal to, why it's always nice to know what y is equal to. So y is equal to 4 divided by x. Yes? Second table. If I go to the table, it's going to give me all kinds of different numbers here. So, view, this here. So if I take a look at my chart here, I put in 1, I got out 4. Put in 1, I get out 4. I put in 2, I get out 2. I put in 3, I get 1.3 repeating. Is that what that is? 1.3 repeating? If I put in 4, I got out 1. Did I get that? Yes. So an easy way of dealing with this, find the k, create the equation. Once you've created the equation, then plug it into the graphing calculator and you can go from there. Okay. So, I'm going to do that. It says k is the constant of variation for this. Is it? I'll give you a minute or so to figure that out. want to know if this is going to work. 3, 4, 5, 6. Is it going up? Yes. 0.5, 0.375, 0.35, 0.25. Is it going down? So it appears that it should be an inverse variation equation. As the numbers go up, it gets smaller. So that means it should look like, probably would help if I had a color you could see, right? Y would be equal to, they say K is 3.5 over X. This is what it should be. Okay? Inverse variation goes up, goes down. Y is equal to, let's plug her in, 3.5 divided by X. Second table. Now, the question is, does it match? So, if I put in 3, I get 1.67. Well, that's 1 2/3, isn't it? If I put in 4, I got 8.75. Is that what I got there? No. I put in 5. No. 6. No. Did this hold? No. It could be an inverse variation equation. I don't know. Okay. But 3.5 did not work as the constant. It's not there. So this one is incorrect. So, let's try this one. Give you a minute or so, work on this one. Okay. Those negatives don't look right in there, do they? We haven't seen negatives in there. So what I'd recommend for you to do is just kind of ignore them right now. We can always go back and check. So I'm just going to kind of set those aside for the time being. And I'm going to look at here. This is going up. Is that going down? Okay. Does it fit the pattern? It seems to. So we weren't given a constant of variation, so what I'm going to do is I am going to take 1/12 should be equal to K over 3. Is that how it gets set up? Considering that our inverse variation is always Y is equal to K over X. So I put in my X and I put in my Y and I got an answer. Okay? So now I'm going to go through and solve. Multiply by 3 here, multiply by 3 here, and I end up with what? Well, 3 over 12 is equal to K, which goes down to 1/4. So it says my constant here should be 1/4. My equation then should be Y is equal to 1/4 over X. Is that legal? Yes. It is very, very much possible to get a fraction for that. So now, we've checked this one. Now I want to see if the rest of these are going to work. Do I want to go through all the work and see if it's correct manually? Not really. Y is equal to. Decimal is pretty easy to come up with here, right? 0.25. So if I put in 0.25 divided by x, second table, let's see what we come up with. So, if I take a look at this, I should see 5 to be 1 over 20. What's 1 over 20 as a decimal? Okay, I know what 1 over 20 is as a decimal. So what do I get? What is it? Is it 0.05? Okay. If I take a look at 9, I get 1 over 36. Well, let's see. 1 over 36 is what? Is 1 over 36 0.02778? You guys got calculators? You can check them out. Is it? Okay. So I'm getting some head shaking over there, so that doesn't quite work. So, if I go and move it up, just out of curiosity, if I put in, well, things aren't working very well here, are they? With the table, with that fraction? My question for you is now, if I were to hit graph, and I see the graph, and I put in 3, back, graph, trace, and I put in 3, I get that number. If I put in negative 0.5, do I get out negative 0.5? Well, yes, I did. So really the only question is on 9. 9, enter. And I get 0.0277, right? Just check. 9, clear out of here. 9 divided by, 1 divided by 36. Hey, it comes up with the exact same number that we were looking for. 0.027, repeating. Second table. I put in 9. And what do I get? Whoop, go down. .02778. Looks like it's the correct thing. So, because these numbers are so big, with their decimals on how they go out, I highly recommend that you go and do it this way. Take one of them, figure out your constant of variation. Once you've got your constant of variation, put it into the equation, drop it into the graphing calculator and check. So, assignment will be due tomorrow and the class.